Hey guys, welcome. I'm going to talk about space today. So, why are we talking about space? Because we hear a lot about space in terms of Space Force, in terms of everyone's trying to go to space. But what is space? Now, there are two definitions. There might be more, but like let's narrow it down to two definitions of space. And one is a theoretical textbook definition of space, which is true no matter what. And the other one you could say is more like a functional, practical definition of space. So let's talk about it and we'll kind of understand what space is. So we are on planet Earth right now. This is gonna be interesting once I explain what space is and once I explain what space means to us or what we see versus what space is. It's gonna blow your mind. So let's talk about the functional definition first. The functional definition of space. So you have the sun, which is right here, and the sun has you get the sun rays. Now you get the sun rays. Now the sun is white. The sun is made out of white light, meaning it's going back to your fifth grade science or fifth grade physics. So all the lights the sun comprises of all the lights in the entire spectrum. That's why it's white. So what happens is when the sun rays, let's use these two now. The sun rays hit the earth. It takes about 8 minutes 20 seconds, let's say a little 8.5 minutes to get to the earth. Now when the sun rays are getting to the earth, what happens is they obviously travel through space, travel through vacuum, there's nothing there. As they get close to the earth, they start entering the earth's atmosphere. When they enter the earth's atmosphere, there is a bunch of dust particles, water molecule, million things that you don't know, we don't know, some things out there. Now what happens is, as I said, the sun consists of white light, meaning that light comprises of all the colors in the entire spectrum. You see when you see a rainbow: violet, indigo, blue, green, yellow, orange, now and red. And then what happens is when the sunlight hits those particles, the light scatters. And that's why when you're a little kid, when you're drawing your picture in the book, why do you make the sky blue? Because the light, so when the sunlight hits the earth's atmosphere, it scatters, and the visible light that is visible to you is blue, because the wavelength of the blue light is a lot similar and easy to scatter. It's easy to scatter when it enters the earth's atmosphere. So that is why you see the sky blue. Now the functional definition, as I said, could be, let's say you are standing here and looking at the sky. Don't look at the sky, but don't look at the sky with naked eyes. But let's say if you're looking at the sky and you start seeing the blue light, the position where the blue light starts, the position where the scattering starts, could be called as the functional definition of space. Now, what is a theoretical definition of space? The theoretical definition of space could be a much simpler way to describe it. But before I get there, let's jump back to the functional definition. Why is functional definition of space true versus not true? Because the scattering of the light is not necessarily at the exact same height. It might be different today it might be different tomorrow. It all depends on how the Earth's atmosphere is reacting at that point. It all depends on how much water vapor, dust particles, everything accumulation around the Earth is happening. So give or take, the Earth's atmosphere, or give or take, the space starts at 62 miles, or let's say 100 kilometers away from the Earth. Now, what's the theoretical definition? The theoretical definition is much simpler and way easy to explain. It is essentially when it literally is essentially you're on the Earth, you're under the influence of gravity. You keep going up, keep going up, keep going up, keep going up, keep going up. After 62 miles, boom, there's no more gravity. That's the theoretical definition of space. So once your gravitational force is not present, you're in space. Once it's present, you're in Earth's atmosphere. Now, that's it. That's plain and simple. That's why a lot of times the theoretical definition makes more sense, because it is uniform and it's a good assumption to have for pretty much the entire physics or entire science, no matter where you're doing, where you're doing the science, or where you're performing the experiment. Now, you know what's crazy? We look up in the sky, we look kind of at a horizon, and we see this infinite, huge, vast sky. But what you're seeing is truly sky, and what you're seeing is truly Earth's atmosphere. But when you look at it from like the whole broad universal perspective, what does that mean? 62 miles. You know how, so you know what's interesting? Should have done it here before, but Michigan and Massachusetts, which is somewhere here, the distance between these two places, or Boston, let's say, is about 620 miles. So go and look on your Google Maps or Apple Maps. 1/10 of that will be like this much. So essentially, that's it. Essentially, that literally is the surface around the Earth, 1/10 of that distance. Think about it. Think about the distance between here, or I'm talking from Michigan, that's why I said here, but think about, well, you know what another good example is? When you're looking at one of those big globes that you'll see in like every high school, every classroom, it probably is what, this big? And that's basically telling you the entire spherical Earth. 62 miles is probably less than 1/8 of an inch, like a little dot. That literally is the Earth's atmosphere around the entire Earth, if you think about it from a broader perspective. So when you're looking up in the sky, sure, you're looking up like a couple 100 feet, or you might have like a visibility of 2 or 3 miles, but it goes way beyond that. But it also isn't that much what you think space is, or what the Earth's atmosphere is. So we literally have 1/8 of an inch on the entire surface of the Earth. Well, 62 miles, but considering if we shrink ourselves down to a spherical globe, which is kind of this big, we only have like about 1/8 of an inch. That's about 3.5, 4 millimeters. That's it, 3 millimeters actually, thickness of Earth's atmosphere. Everything beyond that is space. That's it. That's what space is.